Are electric vehicles a viable solution for energy storage in a microgrid? Hi, I'm Jennifer Hargenrader, and I worked on this project with my mentor, Dr. Wake, and received information from many valuable individuals here at UNH and throughout Durham. The goal of this project was to determine if EVs are a viable solution for energy storage in the UNH Durham microgrid project. To answer this question, a model was developed with three operators in mind: UNH, Oyster River, and Durham Public Works, as well as vehicle types and the EV equivalent characteristics for each type, such as driving range, charging time, and energy use per mile. Three scenarios were developed. Scenario 1 represents a short-term possibility where no more than 25% of each vehicle type in a fleet would be swapped out for an EV. Scenario 2 represents a medium-term possibility, and Scenario 3 a longer-term possibility. The preliminary results for these scenarios are shown in figures 2, 3, and 4. I want to take the time to focus on Scenario 1, figure 2, the short-term possibility. Scenario 1 consisted of a total of 49 EVs out of the 335 vehicles used across all three operators. The light green dashed line represents the UNH campus demand, while the dark green dashed line represents purchased energy by UNH. The turquoise line represents total energy stored in EV batteries, regardless of whether or not the vehicles are in use, and the dark blue line represents the total energy from EV batteries that is available to the grid, meaning that battery charge and whether or not the vehicle were plugged in were both taken into account. Between the hours of 11 p.m. and 6 a.m., the energy from EV batteries that is available to the grid, the dark blue line, is well above the purchased energy at UNH, the dark green dashed line. This shows that during the night, EVs could reduce the energy purchased on campus by a significant amount. From 6 a.m. to 5 p.m., the time of higher demand, the energy from EV batteries that is available to the grid is much lower, due to most of the vehicles across all three fleets being in use consistently. However, averaged across the hours of 6 a.m. to 5 p.m., EVs could reduce the amount of energy purchased by up to 15%. Figure 5 shows the average energy available to the grid from EV batteries for each scenario between the hours of 6 a.m. to 5 p.m. The blue line shows the average purchase power during this time, showing that with increasing the number of EVs, there is a much larger role that they can play in providing energy back to the microgrid. The last thing I want to point out about all three of the scenarios is the turquoise line, showing the total amount of energy available in EV batteries, regardless of being charged or in use. This line shows the potential of using EVs during power emergencies. If certain vehicle types were taken out of use during a power emergency, these vehicles could provide energy back to the UNH Durham microgrid. So are EVs a viable solution for energy storage in a microgrid? Based on the preliminary results from this model, it seems that EVs could play a significant role in reducing the energy purchased from the main grid and improve the resiliency of a microgrid here in Durham by providing backup energy in times of emergency. Thank you.